So now, all of the things that we've done in the past with solving, now we can do some of these solving trig equations without our calculator. In the past, if you would have got sine of theta equals negative root 3 over 2, first of all, it probably would have been in degrees. So instead of between 0 and 2 pi, it would have been between 0 degrees and 360 degrees, which is once around our circle. And you would have typed into your calculator sine inverse of root 3 over 2, the positive ones, because you would have tried to find your reference angle. You might have even drawn a triangle in quadrant 3 and quadrant 4, because that's where sine is negative, labeled your reference angle, found your reference angle, and then did 180 plus your reference angle for quadrant 3. And in quadrant 4, you would have done 360 minus your reference angle. You would have done all that work for this one. Now that we have some values memorized, and now that we have our unit circle, we're going to reduce the amount of time it takes to do a question like this by a lot. All we're going to say to ourselves is, do I have root 3 over 2 as a y coordinate on my unit circle? Yes. What family does that? That's my pi over 3 family. So I already know my reference angle. And I know that it's negative, so I know it's in quadrant 3 and 4. What are my pi over 3 family members in quadrant 3 and quadrant 4? Well, in quadrant 3, we'd have one more than the denominator. In quadrant 4, if we double the denominator and subtract 1, we'd have 5 pi over 3. And we're done. That's all we'd have to do for this question. Some people don't even list the reference angle anymore. They just can write down the answer directly. I know it's part of my pi over 3 family. I know it's in quadrant 3 and quadrant 4, and I can write down the answers directly. So for a lot of these, we're looking, is that value on my pi plate? Because we're going to solve all of these between 0 and 2 pi. Do I ever have negative 1 as an x value on my pi plate? When does that happen? At 180 degrees. And since here this is in radians, and we're done. No need to take out our calculator. No need to do any extra work. Okay? That doesn't mean you can forget how to do that, because we will have some questions where part of the question you can do with your unit circle and your pi plate, and part of this question you still have to use your calculator for to figure out the reference angle, figure out what quadrants it's in, and calculate those angles. Is tan ever equal to 1? What family? 45 degree or pi over 4. So we know that our reference angle is pi over 4. What quadrants is tan negative in? 2 and 4. So in quadrant 2, we'd have 3 pi over 4. And in quadrant 4, we would have 7 pi over 4. Once we get into the reciprocal functions, it's a little bit more work. The little bit more work, you have secant of theta is 2, but all our unit circle stuff is sine, cos, and tan. Change your reciprocal function. Again, the angle stays the same. The ratio, this one was 2 over 1. That's what flips. Cos of theta will be 1 over 2. Is that on our unit circle? What's the family? Pi over 3 family. What quadrants will it be in? It's positive, so quadrant 1 and 4. And sometimes you'll have to do a little bit of work to get sine by itself. In this one, can you see that you could get sine by itself by subtracting 1 and then dividing by 2 on both sides? Do we have that on our unit circle? Yes. So our reference angle, that's part of the pi over 6 family. And because it's negative, quadrant 3 and quadrant 4. So these first set were straightforward ones. The first two were already solved. This last one we had to do a little bit of work. But we will also get some questions where we will have quadratics. And in quadratic trig functions, you have to factor. A reminder of notation that when we write cos squared, and this means cos theta times cos theta, the squared is in between the word cos and the angle theta. Now to start off with, for factoring this, eventually you'll be able to just look at this and factor, but at the beginning you might want to say, I'm going to change my cos's to x, and if I had x squared minus x equals 0, how did I factor that? This is the one where you have a common factor. So we have an x in common each, so you would take that x out, leaving you with x minus 1. That's your factoring idea from last year. So now we just apply that to sines and cos. What do I have in common here? I have a cos in common. So I can factor that cos out. Now, why do we factor? Why do we factor to solve? You were taught this last year, and you probably forgot it and just got into the habit of, yeah, I make one side equal to 0, I factor, I know how to do it. But it's good to revisit why we do these things. And I think I can show a simple example for you that really makes sense. At this first step, x squared minus x are two different numbers. Or they're two numbers that are subtracted from each other. One minus the other one. Okay? Now, if I make up a number in my head, and I tell you I have two numbers that subtract and equal 0, you just have to tell me what one of those numbers are. Go ahead and guess. It wasn't 1. They're just two numbers that I subtracted made equal to 0. It wasn't 4. Wasn't 0. And it's not necessarily the solution to this one. I'm just saying two random numbers subtracting to equal 0. You could guess for a very long time. And I made it extra tricky because I didn't pick a nice, I picked 6.3. How long would you have taken you to guess that? Probably a fairly long time. Okay, so one number is 6.3, the other number would be 6.3, and they subtract to equal 0. So when things are subtracting or adding to equal something, you could guess for a long time, and chances are you wouldn't get it. But when we factor, what we're doing is we're changing subtracting to multiplying right here. And now when we take that same concept, and I say I have two numbers in my head, and they multiply to equal 0, can you tell me one of the numbers? 0. One of the numbers has to be 0. That's the power of factoring. The other number was 2.71828. Anybody have that one? No? Okay, sorry. So when you factor, one of the numbers has to be 0, and it's either the first one or the second one. So if the first one is 0, in this example, x would have to be 0. If the second one is 0, x would have to be 1. And that's the reason we factor to solve, because we change something into multiplying to equal 0, and when you multiply to equal 0, one of those factors has to be 0. Whereas before adding or subtracting, it doesn't help you, because there's so many different things that add or subtract to equal 0. So you don't know what they are for sure. But as soon as you're multiplying to equal 0, you know that either, and that's why we often draw a line here to split it up, either the first factor equals 0, Well, if the first one equals 0, that would make cos theta equals 0. Or the second factor is equal to 0. And if the second factor is equal to 0, sometimes people take the extra step to write out that factor is equal to 0. Most people skip that step and just can do in their head, oh, then cos theta has to equal 1. Probably last year you were skipping this step, right? You could just go directly to saying x equals 1 or cos theta equals 1. Now that we've factored and we've solved these parts, now we can still solve for theta. Is 0 ever an x coordinate? When? Think about your unit circle where the x coordinate is 0. Those are your axes family at the top and the bottom. Is cos theta ever equal to 1? Right at 0 and at 2 pi. Okay? And we have to be careful when we solve questions like this, because we're going to look back at our domain and make sure all of our values are included. So a couple of key things to notice in our domain here. 0 is less than or equal to theta is less than or equal to 2 pi. That means 0 is included and 2 pi is included. You will notice on some of your homework assignments, sometimes the textbook does things like this. 0 is less than or equal to theta is less than 2 pi, which means that 2 pi wouldn't have been included. So when you've done all your solutions like this, you might have to put an x through 1 because it's not actually included. And we've already seen some examples where it didn't just go from 0 to 360, it went from negative 360 to 360, or negative 2 pi to 2 pi. So one thing that you're always going to do in a solving question as a check to end is look at the domain that the question was asking for and make sure that your answers are within that domain in the end. Okay, our next factoring one, or our next solving one. So again, we can think, how would you solve if it was just regular algebra, something squared minus 3/4, what would you do? You would move the 3/4 to the other side and then square root, right? Same idea. We're going to move the 3/4 to the other side. We're going to square root both sides. We're going to remember that anytime we square root both sides, we have to put a plus or minus. And this is where your algebra skills from last year come into play, because the way this is written right now is not on your unit circle. But you can simplify this, because square root of 3/4 is the same thing as square root of 3 over square root of 4. And the square root of 4 is just 2. And now we say, hey, that is on our pi plate. What family is that? That's our pi over 3 family. What answers are we going to get? Well, because it's positive and negative, you have them all. Because you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. It's like a family gathering. Everybody's invited.